Alright, welcome back to another video on Node.js specifically. So yesterday I looked at the multiplayer pong game message, particularly that after look at the UML, this Unified Model Language, okay? So to describe what is the cycle where a particularly uh, application will work. So here we're going to stimulate this pawn message or this pawn multiplayer game. And in case you're not familiar with that, this is a one of the first video games released by a company called Atari in 1973, which is in 1973 it was like that game. So Pawn was released. Pawn, the game Pawn, in 1972. That's right. So 3 years after the ARPANET. Okay. So we're going to take is the non-render logic to the server, but the trade-off with that approach is that now our server is responsible not only to keep the client up to date, but also to process all of this load. For example, calculating is the ball movement and the ball boundaries, and also to another logic as well. So here, okay, by looking at how this might work from the server perspective, uh, by taking is the non-render logic like ball movement out of the socket.io, we make our server theme. So in case we want is to add more complex features or include more players or more instance of that, we can do that. So here we're using is the plain HTTP model to create a server and import that in our socket.io. Okay, so what we're doing is just by creating is a server, we're adding is this middleware layer from the IO, from the socket.io. And we're using is this approach uh, because this is even that this approach is the most verbose, but it's provide flexibility in case we wanted to set an HTTPS or attach an express application. So the interface, like this, so the interface that the socket.io expose is based on the event emitter. Okay, and we already know how to create or how to set up a socket.io server, a plain basic setup socket.io server. Good, good. Now, how can we connect to a socket.io server from the client side? One way to do that is by downloading the socket.io client side library. Use that, and since the HTTP or since the socket.io begin with an HTTP connection and then upgrade to the WebSocket, right? That's exactly what we did. And yesterday we have some issue with the course. So if I want to run this, right? Let me close this. And I'm just going to run the single player pawn. And if we want to run history restore, okay, and it wants to run npm start to run our HTTPS HTTP server with socket.io, alright? And let's go now to open revealing file explorer. Okay, so if we open up this index.html, right? So we have is the pong game. Yes, we have made some change here on the code base because the original code support is the computer AI, right? But right now, because we want us to build a multiplayer pong game, right? So we remove a lot of the code relevant to the computer AI, and here we can see that we're establishing is the socket.io library. So first, socket.io is make an HTTP request, okay, and then it tried to upgrade the request. So by looking here, okay, and if you look at the headers right there, um, so here is where it made it. This is where it switched protocol, right? So this is to this is some at the hands of the client side library to establish an HTTP connection and then upgrade that to a WebSocket connection. Switching protocol, what it's doing is exactly upgrade that connection. And if we look at the console from our server, we already have a user connected. So uh, because each time that we connect to the server, we get a console log. That's the reason why we are. Uh, that's the number of console log that we are here, right? Okay, cool. So, so now it's going to identify connected client. Pretty easy because Socket.io provide
Welcome
is
back. If we go back to our sequence diagram here, we can see that this is the
because Socket.io provide already a unique ID for that. So instead of use a library, for example, UUID, unique identify this UUID, okay, which is a universally unique identifier that is very unlikely to have different or that is very unlikely to have the same ID. So instead of keep tracking of each connected client, Socket.io handle that for us. Great. Thanks, Socket.io, by the way. So we might use something called UUID to calculate or to keep track every single user that connect to our server, to our socket server. However, socket.io client provide a convenient a convenient convenient property that automatically do that for us, and that is on the socket instance. On the socket instance, we have, yeah, on the socket instance we have the socket dot id.
The overall flow of data that we need to support for our multiplayer Pong game. What's the first step that we need to implement? We need to send or emit a message from the client to the server saying that we're ready, that we've finished loading everything we need to load on the client side, and we're ready to play. How might we do this in our JavaScript over here? We can use our socket connection over here with the backend and emit our ready message when we've finished loading, which would be somewhere around when we've created our canvas and shown the intro with the message that says that we're ready and waiting for other players. And this would look something like socket.emit using the socket object where we connect it to the backend, and then the name of our event, so ready, with some sort of payload. And going back to our flow here, we can see that we wanted to notify the server of our player's ID. We need a way of identifying which player it is we're talking about on the server side and on the client side for when we're passing around data and we need to associate, for example, a score with a specific player. But in our JavaScript, we don't really have an ID. We haven't had a need for one when we were single player. Now, we could generate a UUID, or a universally unique identifier, which is like a random unique ID that is very unlikely to ever be duplicated. And we could generate this ID on the server side and, for example, send it to the client so that there's agreement on which player is which. But Socket.io already provides a mechanism for exactly this. If we go to our server API here and scroll down to our socket, we can see that one of our properties is this socket ID, which is a unique identifier for that socket session that comes from the underlying client. That is, it comes from the front end client. And we can see in the client API that we have an equivalent socket ID. But socket ID inside for when we're passing around data and we need to associate, for example, a score with a specific player, which is a unique identifier for that socket session that comes from the underlying client. That is, it comes from the front end client. And we can see in the client API that we have an equivalent socket ID. And we can see this in our front end by using our socket connection, our socket event emitter, and using the socket.on function to listen to the connect event. And what we're going to do in our callback is log the connection ID, the socket ID. So we'll say connected as socket.id. And we do this when we receive the connect event because that's when the ID is assigned. If we reconnected with this same front end, we would receive a new socket ID. So now if we run our Pong game, we should be able to see that connection ID being logged. There we go.
So, because we're going to emit that. Okay. Okay, but this is on the client side. Right. So here, what we're going to do is to implement on the client side, when the game starts, start game here, we're going to emit from the socket, we're going to emit the ready event. Okay, following is the event emitter interface. Okay, so the first parameter is the name of the event and the second is a callback, where here we're just going to send is the socket ID.
And what we're going to do in our callback, if we reconnect it, and we do this when we listen to the connect event, our socket event emitter, and using the socket.on function to listen to the connect event. And what we're going to do in our callback is log the connection ID.
Okay, so this is to emit this event, right? First, to log to indicate the server, hey, we're ready. So this client is ready.
And then the name of our event. So right here we can, and we haven't had a need for one when we were single. Random unique ID that is so that there's a server API is this socket, an equivalent emitter, and using the socket.on function to list.
So okay, this is ready. So we're going to leave that right now. And here, right below here, we're going to implement is socket.on. So when you're listening to the connect,
listen to the connect event. And what we're
so when you do that, so on the callback, you're gonna then send is this data, the socket.io, the socket.id.
going to do in our callback is log the connection ID.
But right now we're going to just to console.log the connection ID. It's just to see that we're doing that properly. So in our client side, right, once we reload the game, we already have a unique identifier.
The socket ID. So we'll say connected as. If we reconnected with the
or connected as like this. Connected as socket ID.
same front end, we would receive a new socket ID. So now if we run our Pong game, we should be able to see that connection ID being logged.
Exactly.
There we go. We get this random looking string to uniquely identify this user. And now we could do the same thing on the server side by logging the ID of the socket session when they connect to our server. And these should match. We should have the same ID on the front end and have the same ID being logged on the back end here. The only difference being that on the server side here, we have multiple sockets being connected at the same time.
So now, here on the server side, we're going is to log is the socket.id. Right. So the only thing is that on the server side, we're going to have is multiple socket ID, multiple client connected.
Whereas in our front end, we only have one socket object, one connection to the back end. So let's rerun our server. And we can actually see that the client that we have in our browser automatically reconnected to our server, which is one of the reliability features that Socket.io provides out of the box. Because we didn't close our browser here, you can.
So once you implement this, Socket provide also reconnection features.
And we can actually see that the client that we have in our browser automatically reconnected to our server, which is one of the reliability features that Socket.io provides out of the box. Because we.
Socket provide a reliability feature out of the box. When a client wants to reconnect, when the client wants to reconnect to the server.
Didn't close our browser here, you can see that when we terminated the old server to restart it, we got a couple of connection refused events, but then automatically reconnected as a new user. So this ID here with the 2PA should match the user in our backend, and it does. This means that we can actually remove the requirement to pass a player ID in the ready event. Socket.io has already provided a mechanism for us to identify each client uniquely. So in this case, we can just omit the ready event and not pass a payload in. Given this new information about socket IDs and how we can use them to identify our players, notice that the flow of our sequence diagram here changes slightly, given this new information. This is perfectly normal in our design process, and it shows that we're getting closer to the actual solution. We're validating the original ideas that we had when designing our flow. Let's keep it up. I'll see you in the next one.
So for this, let me is to create a Git repo. Alright. And here add a Git node. Git dot git ignore like no models or no models, right? So that'll be all. And here we're gonna do is git status git commit minus n or git add all of them. The also will replace CRI in index.html. The file will have its original line endings in your working directory. Mm-hmm. And don't commit yet. To track files, use git add the file, blah, blah, blah. So git status here. If I want to create a new GitHub repo, now especially is for this new repo, multiplayer on game socket. From system master instruction, KD, mastery course, setup multiplayer phone game with socket. Alright. We got a public here. Create a repo for this. You produce an existing repo for that. Let me add this. Okay. So add this repo and all of this. Everyone failed to push on ref because I don't have any commit. Okay. First commit. Or we can just rename this commit by mentioning is identify connected client side. Setting. Yeah, setting up socket server and client. And also you can add a VME later on. Which is a readme.md from multiplayer phone game with socket.io from field mastering. No, that's right. Here, and here you put SD from 0 to mastery academy Node.js course. Okay, multiplayer pong game with socket.io from 0 to mastery academy Node.js course. So if I want to take a look at this, not like that, it's a preview. Okay. I don't know how do you add a hyperlink on Markdown. Syntax. Okay, basic syntax. No hyperlink. Horizontal links. Okay, go, and this. So it's okay, like this. All right, cool. Proceed to my screen and git add, git status, git commit minus n, add readme binding, and then you push this to the main branch, push to this remote repo on the main branch, and that's right. Okay, mm, over HTTPs. Yeah. Git remote delete, remove, remove, origin. Well, if I do this, what the hell? Okay, signing with your browser. Okay. Yes. Authorize this. How? Okay. That's right. Really? Okay. Yeah. Cool. Cool. Now, if I can push this, remote, but everything set up to track remote branch, so it's up to there. So if I reload this website here, and everything is here. That's right. You can play your phone game with Saga.l. Cool. Cool. Alright. Alright. Next is listening on for events in pong server.
Welcome back. Now that our players on the client side have notified the server that they're ready, they've done their part. It's now up to the socket server to listen for this ready event and respond to it appropriately by starting the game. What do we need to do on the server side before the game starts? We need to wait till there's enough players, which for Pong means we need to wait for 2 ready events before we can broadcast a start game event to notify our players that they should begin playing. And the second thing we need to do on the server side is to assign one player as the referee. We'll then let the clients know who the referee is so that they're aware which responsibilities they have. The referee client will take on some additional responsibilities, like keeping track of the score and ball position for both players. On the other hand, the client that's not the referee will have less work to do. Before we start the game, we need to react to those ready events in our server. And on the server side, we only get access to our socket when we're handling a connection event in this block here. Which means this is where we'll add our listener for the ready event by saying socket.on and listening for ready, giving it this callback function, where we'll start by just logging that a player was ready with a certain socket ID. And we'll keep track of how many players have told us they're ready, so we know when we have enough for a game. This will be the only state that we're tracking on our server side here. And we'll say our ready player count begins at 0 and increments by 1 anytime a player sends us a ready event. And when we have enough players for a game of Pong, so 2, which means the ready player count will be 2, we'll do something to broadcast this start game event. Let's find out exactly how we're going to do this broadcast in the next video. Welcome back. How exactly do we broadcast events in Socket.io? Remember, we had multiple different ways to broadcast.
Just listening for event.
Welcome back. Now that our players on the client side have notified the server that they're ready, they've done their part. It's now up to the Socket server to listen for this ready event and respond to it appropriately by starting the game. What do we need to do on the server side before the game starts? We need to wait till there's enough players, which for Pong means we need to wait for 2 ready events before we can broadcast a start game event to notify our players that they should begin playing. And the second thing we need to do on the server side is to assign one player as the referee. We'll then let the client know we need to react in this block here function, where we'll start by just logging that a player was ready when we're handling a connection event in this block here. Which means this is where we'll add our listener for the ready event by saying socket.on and listening for ready, giving it this callback function, where we'll start by just logging that a player was ready with a certain socket ID.
So he was trying to listen to
And
this
we'll
event.
keep track of how many players have told us they're ready, so we know when we have enough for a game. This will be the only state that we're tracking on our server side here. And we'll say our ready player count begins at 0.
Counts for the log is the player one. Okay. Meaning that in our case, once we receive this event that is emitted from the client, so right now we just only to console log and say, well, a player ready, with the socket that ID, which is their unique identifier for each client, for each connected client.
And increments by 1 anytime a player sends us a ready event.
And you have let ready player count. You define this like that. Let ready player count to 0 at the beginning. Okay. And right after that, you're going to increment is
And when we have enough players for a game of Pong, so 2, which means the ready player count will be 2, we'll do something to broadcast this start game event.
okay. So when the ready player count is equal to 2, we're going to do something to broadcast this event. the broadcast the start game.
Let's find out exactly how we're going to do this broadcast in the next video.
The start game.
Welcome back. How exactly do we broadcast events in Socket.io? Remember?
So, depend on the use case, and this is something important here. So, broadcasting events, listen to event, and then broadcasting to event.
Remember, we had multiple different ways to broadcast. If we go to our Socket documentation and check out this emit cheat sheet, we can see that one form of the broadcast sends messages to all clients except the sender, where the sender is the current or the latest client to send or emit a message to the server. And we can do that using this socket.broadcast.emit function. Where the second way, if we scroll to the bottom here, is by calling emit on our IO object, which will broadcast to all connected clients. And this is what we'll use to start the game. After all, every client needs to know that the game should start at the same time. And they all need to know.
So this is the socket, or this is the method to broadcast to all connected clients when we start the game. Right?
The game.
This is what we're gonna
After all, every client needs to know that the game should start at the same time. And they all need to know who the referee is so they can decide what they're responsible for. Now, back in our code, this means that our broadcast function will be io.emit. And to identify who the referee is to the clients, which was our second parameter here, we'll send them the ID of the chosen referee. And by passing in socket.id here, we're effectively choosing the second player who tells us that they're ready.
Exactly. So by passing here is we're choosing is this. By passing is the socket.id, we're choosing is the second player as the referee for our game.
As the referee. We're sending every client using our broadcast the socket ID that we have access to in this block, in this connection block, when our player count reaches 2. Again, we've adjusted our sequence diagram, making it a bit more explicit. Instead of sending each client a boolean representing if they're the referee or not, we instead send the ID of the player who will be the referee. This way, on the server side, we can send the same event with the same data to all clients, simplifying our design, which is always good. I'll see you in the next one.
Okay.
Welcome back. Our server has sent each client the start game event. Now, what do we need to do on the client side to start the game? We're going to add a handler below our connect handler for our start game event. And our start game event has a parameter, which is the ID of the referee. So we're going to take in the referee ID. And we can log this for testing purposes. The referee is the referee ID. But now we need to keep track of whether this player is the referee or not, so that we know whether we are the ones to keep track of the score and keeping track of the ball position. So we're going to add a variable at the top here and say that we default to is referee equals false, referee with just 2 E's here. And if a certain condition is met, then we'll set is referee to true. We know that we're the referee when our socket ID
match
for our client, which we've initialized here at the very top, we know.
Okay. git status, git add to git commit here -n. Yeah, git add git commit -m. The git commit -m here is to broadcast starting. Is going to main.
For the referee, when this socket ID
Here
initialized here, referee, then we'll set is referee.
So when, so for example, here on the client side, you're setting it as the referee because this will be responsible to avoid cheat players. So is referee is a boolean as false, and then on the game star game here, okay, and start game. So when you listen to that, when you listen to the socket that on start game, you now going to receive is the socket. Well, you're going to receive is referee for them. And actually this is not its referee because it's not a boolean. This is the referee ID for that. Okay, and then you want to know you want to know who is the referee here. So easy way to do that, because to know who the referee is, also log here at the referee is the referee ID. Okay. And here is just know that is the referee will be is if the referee ID is equal to the socket .id. Alright?
Referee to true. We know that here matches to start the game. But our start game function over here that runs on load does a little more than what we need here. It handles both the three things
Then he's going to start the game.
here that we need on load, and then all of these actions here, which need to be executed when the game actually begins. Let's separate the game loading code from the game starting code. So we'll say that this is the load game function, and call load game on load, and then we'll create another function here below load game that is start game. And it's in this start game function that we will begin the game loop and start listening and responding to user input. And let's just make sure that our comments here are relatively accurate. And we can call start game when we've received the signal from the server. Now, if we go to the start game function, we'll notice we have this paddle index variable, which is hard-coded at 0. This represents the paddle that the current player is controlling. In single player, it made sense for it to always be 0, which meant that the player was always controlling the paddle at the bottom of the screen. which we can see in our render canvas function, the paddle with index 0 is the bottom paddle. But with multiplayer Pong, one player will be controlling the bottom paddle, and the other one will be controlling the top paddle. So in our start game function, we'll determine who controls which paddle based on which player is the referee. Now we could decide this randomly or using any logic that we want, but in our case, let's just say that the paddle index for the referee will be 0. So the referee controls the paddle at the bottom of the screen, and the non-referee player will control the paddle index at 1 at the top of the screen. Now we've set up our game and we're ready to start playing. Let's test our code and make sure that the game is starting correctly and the referee is being assigned. So we'll do npm start, and now we can start two browsers side by side and see if both get the signal to start the game from the server. And now we have our game starting, with my player input at the bottom here working, and if I click on the window on the right, I'm now moving the paddle at the top. But you can see that there's been a disconnect between the player on the left and the player on the right. The scores don't match up, and the position of the paddle on the bottom and on the top here doesn't match up, and neither does the position of the ball. So we'll need to synchronize the data between both clients. But for now, let's make sure that the referee is being assigned correctly. So we can see that on the left we have this player ID, and on the right we have this player ID, where the left one is the referee, and the one on the right is the non-referee player. On the server side, we can see that we got two users who connected, and they both sent player-ready events. Amazing! We're ready to implement the multiplayer game logic and keep the clients in sync. I'll see you in the next one. Welcome back. Disconnect between...
So that'll be all for this video. Take care. Bye-bye.